Today in this module I have developed a case study on GARCH model analysis. It is generalized autoregressive conditional heteroscedastic model in R. Especially for this particular module I use the R package, that is F-GARCH, and I will start with the simulated data based on the F-GARCH, and I will show you how to fit the GARCH one model, and then how to see the validity of the model through the model diagnostics after fitting the GARCH model. And then at the end I will take a real life data and I will show you how to select the appropriate order of the GARCH model, and after fitting the model similarly I will show you in the real life data how to see the validity of the model fit based on the regression diagnostics plots as well as some tests. So, let us focus on the demonstration for GARCH model. The main outlines for these demonstrations that I mentioned earlier, the illustration of GARCH by R using F-GARCH package and apply GARCH 1.1 in a simulated data model diagnostics and apply GARCH in a real life data. So, first we will look how to simulate the data for a GARCH model. In the F-GARCH function package has the options for simulating data from the by setting the initial parameters as omega, alpha and beta. So, for omega is I assume 0. Very small, just to ignoring the air component from the data, just only focused on the noise part, and alpha is assumed to be 0.18 and beta was assumed to be 0.59, and then once you set this value, then you can call the library F-GARCH. If it is not there in your computer, you can install by F-GARCH and then specify the parameters. Just GARCH spec, one function is available in a F-GARCH package, that GARCH spec there you can just assign the model parameters as model equals to list, omega equals to very small, that I assume, alpha equals to 0.18 and beta equals to 0.59. There is a spec object that can be stored in any names. I here write as spec. A spec is an object that stores the model specification, that means all the parameters of the models that is required to generate data, to simulate the data. So, the main function that you have to use here to simulate the GARCH data is the GARCH sim. S is caps, so GARCH SIM sim. There you just pass the GARCH spec object and then mention the number of time points that will generate your data in this manner. So, it will take the date that you are generating and it will go backwards, and the daily data that will be provided for this function. This function will provide the daily data with respect to the date, and that was the GARCH 1.1 generation. Suppose you want the GARCH 1.2 order 1.2, then you have to set two parameters for beta, and the two parameter beta that I assumed here, for omega again I said that the air component is quite small, deliberately to ignore the autoregressive components, just focused on the noise. Alpha is 0.18 and beta is set to both 0.4 and 0.4. So, similarly you can generate a spec function variable by GARCH spec model list equals to omega, then alpha, and enter beta. Beta is a vector, and then spec sim, specify the total number of sample that you are looking for, and then you enter, that will generate your data. So this is the data for GARCH order 1, 2, and similarly you can generate any kind of data of different orders for the GARCH model. So let's generate the data for illustration. I deliberately make the simulation is very simple for your understanding. I just took a GARCH order 1, 1 and generate the data and fixed omega equals to 5.5045 and alpha equals to 0.2, beta equals to 0.7, and then finally GARCH sim function was called and the 500 data points was generated, and the data was stored in a variable called data. And you can, if you want to display the data header and tail, just write head data and the tail would be displayed by tail function. That will give you the idea about the data that you have generated by GARCH sim function. So the first exploratory analysis would for any kind of time series is a time series plot. So to draw a time series plot, you can just call the function plot and type equals to L. That will generate the time series functions, looks like this, and then other plots are the ACF, PACF. For ACF, just ACF pass the data and mean equals to y, and PACF mean equals to y. The ACF of the y square, ACF, PACF of the y square. I just wanted to put all 4 plots together. So for that, here I set the pair MF row equals to C2, 2, and that will create total 4 column, 4 cells, the 2 by 2, 2 rows and 2 columns. So total 4 plots can be accommodated in this manner, and finally a pair MF row C1, 1 was set back to the original structure of the plot. So it will generate the all the plots that you need. Here if you see the y square, y ACF and PACF, that means without squaring, is not showing any, it's not showing any significant lags, but whereas if you take the square, its square is showing in the ACF around 1, PACF is 1. Maybe GARCH 1, 1 might be appropriate, because that is quite obvious, because I set the, while I generating the data, that time I set as GARCH 1, 1. So that's why it was also displaying that the order of the GARCH should be 1 and 1. And you can also test the arch effect by the arch test data, that is, that particular function is available in FinTS library. That if you don't have, you can install the FinTS library and you just pass the data within arc test. This is one of the function of the FinTS library, and that will give you the data and it results, and it's showing yes, there is a significant arc effect. Arc is significant. So that's the word I set while I simulated the data as 1, 1. So at least 1 lag is there. While you feed the GARCH, I'll two-way I'll feed the GARCH here. First, the TCA function, TCA library that I use here first, and that in the TCA library the function is simple GARCH. So there you can pass the data and specify the order, and trace equals to false, just to avoid the intermittent steps, the iteration steps. It will directly give you the results, and that object was stored in G11 variable, and G11 is actually GARCH object. It has all the results. If you want to get the summary can be generated by the summary function G11, and it will give you the summary G11. It is, the effects is quite similar, but it is not exactly what I assume. That's the problem for GARCH fitting, there is no unique methods is available to get the accurate get the results, estimate the parameter uniquely. So different methods will give you little bit different results, but subject to comparison. But my intention here is not to compare the methods, rather I wanted to show you how to analyze the GARCH model. And here also the residual square residual L-Jung box test p-value also provided here 0.84, which is not significant. So it's indicating no more further autocorrelation is there. So model is quite good. A G11 model is the appropriate for this data. So these are the main information that you might look for. If you just want to see the diagnostic plots, very easily it can be generated. Just pass the G11 object, the GARCH object, within the plot function, and it will, every time you enter, it will generate different type of plots. In the first plot you will see the raw data, and then the residual. The residual is showing quite randomly scattered over 0 line. Then it will generate the histogram. Next hit will generate a QQ plot. QQ plot also showing fair fitting of normal distribution, so there is no issue. And ACF square and PACF square, ACF square data and ACF squared residual would be provided. These are the 4 diagnostic plot can be generated by the GARCH object that for the function TSA. As I mentioned that I'll also show you how to analyze the GARCH through fGARCH package. For fGARCH package there is a function called GARCH fit. So GARCH fit, there you have to mention data, then tilde symbol and GARCH 1,1, and then here also if the data is not only the noise but some significant error components are there, so that also can be accommodated in the GARCH fit. For further information you can get the help of GARCH fit, that might help you to further fit different choices of models. And the summary will generate the results. As you can see, the results are not same, it will vary across different methods, as there is no unique methods exist. And the same way you can get the test. Here also L-Jung box test p-values are provided, and clear that nowhere it is significant. So there is no evidence of non-normality exist in the residual. So fitting was quite good. NAIC also provided 1.25. For the diagnostic plot of fGARCH package, if you can store the GARCH fit object in a variable, say fit, and plot that fit, then it will give a list of the diagnostic plots from time series studies, conditional standard deviation, series with 2 conditional SD superimposed, then ACF of the observations, ACF of square observations, cross correlation, residuals, conditional SDS, standardized residuals, ACF of standardized residuals, then ACF of square standardized residual, cross correlation between R square and R, QQ plot of standardized residuals. So when you need, and whichever you need, you just have to type the number that is listed left side corresponding to the name of the plots, and if you want to get out from this loop, just enter 0, you can come out to the console. So next what we will do, I use a real life data to fit a GARCH model, and there the step by step methods that we used, same way we apply in the real life data. Data was taken, it's monthly IBM stock returns data that was taken from the following website mentioned here. and just to get a time series plot, I just took the data that is in first column, the data, the first column I plotted, that is the IBM stock return. That IBM stock return, it looks like this, it's indicating some volatility, of course, from here itself. For exploratory plot, again, I'll do a ACA, PACF of the data, then ACA, PACF of the square data, and that will, and also the ARCH test can be performed with the data, and that will, ARCH test is significant, there is ARCH effect, but I don't know what is the order of that ARCH component, so that need to be derived based on the AIC. So these are the diagnostic plots. It's giving some indication though, but it is not clear what would be the appropriate order of GARCH model. For that, we better look for the AIC fitting the different for the different choices of the model. So for GARCH fit, you can just get the summary of the GARCH fit. Say here GARCH 10 I used, and then you can get the different AICs for choice of 10, 20, 30, 11, 12, 21, 22, and out of all the AICs that was observed, the least AIC was 1.124. So that means GARCH 1, 2 should be the appropriate choice for the model. So then we can fit the GARCH model, that is GARCH fit data $GARCH 2,0, that is just fitted, and summary can be generated. But the final model, that would be 1, 2. So this was used to generate the AIC value, because once you generate the summary, that will give you the AIC value, and but the final model would be of the order 1, 2, that is the GARCH choice, and this is the corresponding to 1, 2, the results would be displayed like this, and mu is almost 0. So error component is almost negligible, and it is also not significant, only focus in the noise part. And here also, if you can see that L-jump box test are all insignificant, and that indicating that there is no autoregression in the residuals. So fit is almost quite fair. But the diagnostic plots, let's look at the diagnostic plots the same way as I mentioned earlier. The plot fit G12 was the variable that I stored the GARCH object for the final model of order 1 and 2, GARCH order 1, 2, and that will show you the diagnostic plots. The first one is the residual plots, the second one is the ACF of the standardized residuals, third one is the standardized residuals of the series, and the fourth one is the QQ plot, and the QQ plot indicating quite strong violation of normality. If you see the two extremes are actually far away from the line, and that indicating some violations of normality. So the normal distribution that I assume may not be appropriate for this. So we should go further. That is, you can, instead of normal distribution, that is the conditional distribution, instead of normal, you can look for other distributions that are available. So most common is the T distribution, because it would be quite steep distribution compared to normal. So T might be the appropriate distribution for approximating this distribution. So why you can choose any distribution, but here just sake of understanding, I took a T distribution as a conditional distribution. So the for selecting the conditional distribution T, you have another parameter in the GARCH fit is a con.dist, there you can select, for normal it is NORM norm, and for student T distribution it is STD, that means student T distribution, and you can refit the model with T conditional distributions, and then you can get the summary by summary function. This is the results. Minor modifications definitely is there. And if you look at the QQ plot again, same way you can generate all the diagnostics, but I just look for only QQ plots to see whether any the fitting is quite fair or not, but it is indicating that it is much better fit than the normal distributions. So, I mean, that indicating that T distribution might be a appropriate choice for the conditional distributions. So, that all about GARCH data analysis. In this module, what we have done is we just generated a simulated data based on GARCH. The GARCH package has some option for simulating the GARCH model, where we ignored the AR part, just the residual part we considered, and we have seen how to fit the GARCH model, how to see the different regression diagnostics, and from there how to assess the appropriate order of the GARCH model. And then finally we took a real life data, there we fit the GARCH model, and we have seen that not always the normality is true. We checked with the QQ plot that it is not fitting well with normality. Then finally we use a student T distribution as a conditional distribution, and that gave a quite fair fit. Hope after completion of this module you would be able to understand how to analyze the GARCH model in R.